So today I'm going to introduce you to the rules of exponents. The rules of exponents. What are the rules of exponents? Okay, so say for instance you have a multiplication problem, a quotient problem, and a power problem, and they all have exponents. They all have exponents to them. I tell you what, let me tell you what they would look like. These are just basic examples. They're going to look worse than this here. Either way, I'm still going to help you out. You see how the first in your first section right here, x times x times x times. In this particular situation, you have x raised to the first power, because don't forget now, in math, they say that regardless that there's an imaginary one right here. They just don't write it, but there will always be an imaginary one. So remember that. Let me go ahead and take that off. So we have x to the first times x to the fifth times x to the second times x to the third. So what we would do to solve this problem is use what we call the product rule. And I will show you what the product rule looked like. Look at the next section next to it. That's a division problem, right? AKA a quotient with exponents. X to the fifth divided by x cubed. So to solve this problem, we would use what they call the quotient rule. And then in the next section, over here to the far right, x is raised to the third power and also raised to an exponent. It is also raised to an exponent. So we would use what they call the power rule. So let's start off with the product rule. So the the definitive definition states that if x is a real number and n and m are integers, then x to the m times x to the n will equals x to the m plus n. In other words, when you have a base of x, this would be considered the base. In other words, the base would mean in this particular situation that all of the numbers or all of the variables will look the same. It will look the same over here, and it will look the same over here. You still have the same base. The only thing that you'll be doing is adding their exponents. Adding the exponent. Let's go ahead and get our feet wet. All right, so you have x to the, remember that first right there? You have x to the first times x to the fifth times x to the second times x to the third. So our base is going to equal x, right? So now, as a matter of fact, let me go ahead and circle it over here where we have the formula at. So now, all we have to do is add up the exponents, which is 1 plus 5 plus 2 plus 3. And what does that equal? Okay, 6, 7, 8, 11. So our official answer is x to the 11th power. X to the 11th power. That's our official answer. Let's go to the next one. Don't be alarmed. Do not be alarmed. Just because you see some a plus b inside parentheses, it's still the same technique. It is still the same technique. What is our base? Our base is a plus b. That's our base. And we have three bases up there that have exponent along with them. So we can say 4 plus 2 plus 3. Let's go ahead and break it on down here. So our answer would be a plus b to the, let's see, we have to count up our base. 4, 5, 6, 9 to the 9th power. to the ninth power. A plus B to the ninth power. Let's go again. I ain't done yet. Same thing, but only this time we have a cubed. Why are you looking at the a cube? You don't have to look at the a cube to be honest with you because it does not match a base. But one thing we do know that this is a product. That this is a product. B squared to the a cubed times b to the negative 4. But we do have a similar base on the inside, and that represent the b's. The base will equal the b. And we still can carry out and we still can bring out those exponents 2 minus 4. Now see, normally we can still write it in, not to cause no confusion. It still be like this here, 2 plus the negative 4. But regardless, you're still going to get the same answer. So just get rid of that. So let's just take this. You're still going to get the same answer. So we just use the 2 minus 4, in which we will get, in which it equals a negative 2. Okay? So let's go ahead and bring everything down here. So we have b to the negative 2. Uh-oh, don't forget about the a cube. That a cube didn't have nothing to do with us, but it's still part of the problem though. So let's bring it on, right? But we're not done yet. We're not done yet. Remember in the video that I created about negative exponents? Let me write that rule down over here. Negative exponent. Remember that video? If not, go back and watch it. When you have a negative exponent, it will equal 1 over the base and a positive exponent. You see that? A positive exponent. So we have the same thing here. We have the same thing here. So let's go on down here. So we have b to the negative 2, which would be 1 over b squared. And let's not forget the a cubed. Okay? Now we can simplify this so it'll look good. We got to make it look good, right? So let's go ahead and put the official answer right here. So the official answer is a cubed over b squared. Because if you look right here, this is just a multiplication. If you look right here, this is a cubed times 1. So why not just go ahead and just bring everything, just put it together. So this is your official answer. Ladies and gentlemen, I just introduced you to the product rule of exponents. So the next thing that we're going to do is the quotient rule. I'll go ahead and add that in the next video. Thank you for joining me. I'll talk to you soon.